Good morning, grade 9. Okay, now inshallah we are going to take new session in chemistry sessions. Okay, I hope that you will enjoy inshallah with this session, and I'm pleased to join with me in this session. It's okay, guys. Let's begin. First, listen please.
Section 1. Light and quantized energy. Light, a form of electromagnetic radiation, has characteristics of both a wave and a particle.
Okay, so in the title of our session, which is called Light and Quantized Energy. Light and Quantized Energy, okay? So light is a form of electromagnetic radiation. Light is a form of electromagnetic radiation, has characteristics of both wave and particle. Both wave and particle, it's okay? Can you read, Bassami, this paragraph, please?
Yes, Mr. Light, a form of electromagnetic radiation, has the characteristics of both a wave and a particle.
Good, thanks, Bassami. Can you read again, Tamer? Tamer, can you read again?
Yes, Mister. Light from a form of electromagnetic radiation has characteristics of both a wave and particle.
Thanks. Hosam, can you read again, Hosam, please? Hosam? What is Hosam? He left or no? Okay, Asmari. Asmari, can you read again, please?
Yes. Light, a form of electromagnetic radiation, has characteristics of both a wave and a particle.
Okay, thanks. So after that, this is an essential question that we are going to explain and study in this session. Listen, please.
Essential questions. How do the wave and particle natures of light compare? How is a quantum of energy related to an energy change of matter? How do continuous electromagnetic spectra and atomic emission spectra compare and contrast?
So this is the questions that we are going to explain and answer, okay? How do the wave and particle nature of light compare? How is the quantum of energy related to an energy change of matter? How do continuous electromagnetic spectra and atomic emission spectra compare and contrast, okay? Hashim, can you read the first question, Hashim, please? Hashim?
Yes, Mister.
Yes. How are you, Hashim? I miss you.
Fine, thank you, Mister.
Happy Ramadan, my friend.
Happy to you too.
Okay, thanks. Can you read the first question, please?
Yes. How do the wave and the particle nature of light compare?
Okay, thanks. Bassami, can you read second question?
Yes, Mr.
Yes, second question.
How is the quantum of energy related to an energy change of matter?
Okay, thanks. Thamer, can you read third paragraph?
Yes. How do continuous electromagnetic spectra and atomic emission spectra compare and contrast?
Okay, thanks, my friend. So the vocab that we studied before as radiation, okay, radiation. But the new vocab that you are going to study in this session, okay, please listen well to this listening, okay?
Electromagnetic radiation. Wavelength. Frequency. Amplitude. Electromagnetic spectrum. Quantum. Planck's constant. Photoelectric effect. Photon. Atomic emission spectrum.
That's okay. So, Asmari, can you read the first three, please?
Yes.
Can you read the first three words?
Okay, electromagnetic radiation, wavelength, frequency.
Wavelength,
Yes.
and frequency. It's okay. Bassami, the other three words.
Yes, mister. Quantum.
No. Amplitude.
Amplitude, electromagnetic spectrum, quantum, Planck's
Quantum.
constant.
Okay,
Yes.
thanks. Planck's constant. Okay, thanks, Ahmed. Thamer, the last three, please.
Photoelectric effect and photon and atomic emission spectrum.
It's okay. Thanks, Thamer. So after that, we are going to study this question, the atom, and an unanswered question. The atom and an answered question. Okay? So recall that in Rutherford's model, the atom's mass is concentrated in the nucleus and electrons move around it. As we said before and studied that atom, okay, the atom has a nucleus. Any atom consists of two main parts. Any atom consists of two main parts, which are what and what? Two main parts, which are what and what? Okay, number one, nucleus that has protons, positive protons, and neutral neutrons. And there are electrons that revolve around the nucleus in 7 energy levels, which are called KLMNOPQ. Okay, so this is as Rutherford explained before, that any atom consists of two main parts, nucleus and electrons that revolve around the nucleus. So the mass of atom is concentrated in its nucleus. Why? Because nucleus has protons and neutrons, and the mass of protons and neutrons, okay, mass of protons and neutrons is larger than the mass of electrons that revolve around the nucleus. So the mass of atom is concentrated in its nucleus. Understand me? After that, the model doesn't explain how the electrons were arranged around the nucleus. The model doesn't explain how the electrons were arranged around the nucleus. Okay, he said before that around the nucleus there would be electrons, but he doesn't explain what is the electrons arranged, okay, and how arranged around the nucleus. The model also doesn't explain why negatively charged electrons aren't pulled into the positively charged nucleus. Okay, all agree that any positive charge can be attracted to another negative charge. So, in Rutherford model of atom, he doesn't explain that how electrons that have negative charge, how electrons that have negative charge can revolve around nucleus, while nucleus has protons which have positive charge. Okay, so this is no how this. Okay, how this. Okay, so he doesn't explain this. He doesn't explain why negatively charged electrons aren't pulled into the positively charged nucleus. Okay, as we said before, although electrons have negative charge, while protons, which are found inside the nucleus, have positive charge. Why? This negative charge can't be attracted to this positive charge and revolve around the nucleus without any attraction. He doesn't explain this phenomenon. Okay? Also, in the early 1900s, scientists observed certain elements emitted visible light when heated in a flame. Okay, in 19, scientists observed certain elements emitted visible light when heated in a flame. Okay, An analysis of the emitted light revealed that an element's chemical behavior is related to the arrangement of the electrons in its atoms. Okay, so the chemical behavior, scientists observed that the chemical behavior of these elements are arranged of the electrons in its atom. Okay, according to the arrangement of these electrons around the nucleus of each atom, so the chemical behavior of each element will differ from the other one. Understand me? Okay, any problem till now, guys? Any problem? Any problem till now? Okay. Who is iPhone? Who is it? Who is iPhone? Can you introduce yourself? iPhone. The name of iPhone. Can you introduce yourself to record you in participants now? If you didn't introduce yourself now, okay, I will remove you from this meeting. It's okay. Any problem till now, guys? Okay. Any problem? Please, all guys, can raise your hand. All guys can raise your hand. Okay, Bassami. Okay, Thamer. What about the other? What about the other? What is Hashim, Hussam, and Asmari?
Here,
Yes,
Mr.
Mr.
Okay, I said before, raise your hand. Hashim and Asmari, raise your hand, please, okay?
كيف نرفعها هسه ما أعرف.
Okay, there is option of raise hand. You have an option that raise your hand, okay? Can you raise your
أيوة
hand?
لقيته.
Okay, thanks, Hashim. Okay, guys, understand till now? Any problem?
Yes.
Any problem?
No.
It's okay. Let's complete. So listen, please, to these words. Listen, please.
The atom and unanswered questions. Recall that in Rutherford's model, the atom's mass is concentrated in the nucleus and electrons move around it. The model doesn't explain how the electrons were arranged around the nucleus. The model doesn't explain why negatively charged electrons aren't pulled into the positively charged nucleus. In the early 1900s, scientists observed certain elements emitted visible light when heated in a flame. Analysis of the emitted light revealed that an element's chemical behavior is related to the arrangement of the electrons in its atoms.
Okay. After that, we are going to complete about the wave nature of light. Okay, so visible light is a type of electromagnetic radiation. Visible light is a type of electromagnetic radiation, a form of energy that exhibits wave-like behavior as it travels through space. Okay, Okay, so it's visible light. The meaning of visible light. The wave nature of light, as we said before, visible light is a type of electromagnetic radiation, a form of energy that accepts wave-like behavior as it travels through space. Okay, visible light. After that, all waves can be described by several characteristics. All waves can be described by several characteristics. The wavelengths, what's meant by wavelengths? Wavelengths is meaning, okay, it's simple as inverted Y letter. It's a symbol of wavelengths. What's meant by wavelengths? is the shortest distance between equivalent points on a continuous wave. Is the shortest distance between equivalent points on the continuous wave. It's the meaning of wavelength. Okay. So who can answer me? What about wavelengths? Thamer, can you read it again? What's meant by wavelengths, Thamer?
Yes. The wavelength is the shortest distance between equivalent points on a continuous wave.
It's okay. Thanks, Thamer. Asmari, can you read it again, please?
Yes.
Ahmed,
Yes. Meaning of
I,
wavelengths.
ha- I
Uh,
have to go.
the wavelength
What, Hashim?
is the
Wait,
short.
Asmari. What do you want, Hashim? What do you need?
I have to go bathroom. I can go.
It's okay. Okay, my friend. Okay, Asmari, can you complete?
The wavelength is the shortest distance between equivalent points on a continuous wave.
In a continuous wave. Okay, thanks. But Sami, can you read it again?
Yes,
The meaning of wavelength?
yes, mister, is the shortest distance between equivalent points on a continuous wave.
It's okay. Thanks, Bassam. Thanks. After that, after wavelengths, the frequency. Frequency has a simple V. Frequency has simple V. What's meant by frequency? Is the number of waves that pass a given point per second. Number of waves that pass given point per second. Frequency as channel frequency. Okay, when you try to adjust the channel of TV, okay, you can search about its frequency. So frequency means what? The number of waves that pass a given point per second. It's okay. Okay. Can you read it again, Asmari? The meaning of frequency?
Frequency.
Yes.
The frequency is the number of waves that pass a given point per second.
Okay, thanks. Thamer, can you read it again?
Frequency is the number of waves that pass a given point per second.
Thanks. Bassami?
Yes, is the number of waves that pass a given point per second.
It's okay, thanks, Bassam. Hashim, are you here or no? Hashim? Did you come from bathroom or no? Okay. After frequency, okay, amplitude. What's meant by amplitude? Amplitude is the wave's height. Wave's height from the origin to a crest. Okay, amplitude means what? Amplitude is the wave's height. Wave's height from the origin to a crest. It's called amplitude. So its maximum displacement. We can define it again by another concept that it means the highest displacement done by wave away from its original position. Is amplitude. So amplitude, its maximum displacement. Maximum displacement done by wave away from its original position. It's called amplitude. Okay, as this. This is drawing that explains the meaning of wavelengths, amplitude, and frequency. This wavelengths, as we said, wavelengths is the shortest distance between equivalent points on continuous. This is called equivalent. From this crest, this point called the crest. This called the crest. But this lower point called trough. And this also called trough. So, wavelength is the distance between two successive crests. Two successive crests means from this point to this following point, or two successive trough from this point to this successive point. It's called wavelength. So wavelength from this point to this point, or from this point to this point. It's called what? It's called wavelength, as shortest distance between equivalent points on a continuous wave. Okay, amplitude means what? Amplitude, it's maximum displacement done by this wave away from its original position. This is original position. And maximum displacement was here. Maximum displacement was here. So it's called amplitude. Amplitude may be outward, may be upward or downward. Can be also downward. From this origin point to this. From this origin point to this. It's called also amplitude. That's the meaning of amplitude. It's maximum displacement done by wave either upward or downward. It's called amplitude. Okay?
Okay, Mr.
Okay, welcome, Ashim. Frequency means what? Frequency is the number of waves that pass a given point per second. Frequency is the number of waves that pass a given point per second. And this number of waves, this and this, it's called wave. Till this point, called wave. This half wave, and this another half wave. So till this point, it's called wave. This wave. Okay, this what? This wave. And from this point to this half wave to this again, it's called wave. So this drawing has what? This drawing includes two waves. From this to this point, it's a wave. And from this to this point is another wave. So this shape includes two waves. Okay, and this is the meaning of what? This is the meaning of what? The meaning of each is the meaning of each amplitude, frequency, and wavelengths. Amplitude, frequency, and wavelengths. Understand me? Hashim, can you read, please, what's meant by amplitude?
Yes, Mr. The amplitude is the wave height from the origin to a crest.
Okay, frequency again?
Frequency is the number of waves that pass a given point per second.
Wavelengths?
The wavelength is the shortest distance between equivalent points on a continuous wave.
On a continuous wave. Okay, excellent. So understand, guys, these three concepts. Okay.
Yes.
Okay. These three concepts are related to this diagram. Okay. This diagram explains the meaning of wavelengths, frequency, and amplitude. Understand this? Any problem till now, guys?
No.
Okay. I think that the session will be ended now. Okay. Thanks, guys, for your participation. Okay. Big thanks for Bassami, Thamer, Hashim, Asmari, okay, to participate with this session. Okay. And I hope that you will enjoy, inshallah, with your time and with your chemistry session. Okay. I'm pleased, guys, to contact with me. Okay. Thanks, guys, for your participation. Okay, happy Ramadan. Thanks, Ahmed. Thanks, Hashim. Goodbye and happy Ramadan, guys. Okay, goodbye. See you soon, inshallah.